Hi, I'm Shobha, and in this video, I'll show you how to author custom content. I will show you how to create this spacer so that we can insert it from the content library, just like any other standard part shipped with AutoCAD Mechanical. Let us start with this drawing. This drawing already has all the geometry we need for the spacer. First, I add this geometry to the content library. Then, I give it a name and save it. While saving, I specify where in the content library it should appear. I hit test to check if everything is okay. Next, I'm going to make the spacer resizable. I constrain the geometry to ensure that it will not go out of shape when I resize it. First, I add the geometrical constraints. Next, I add the dimensional constraints. Notice that I changed the default name of this constraint to hole diameter. I will show you its significance later. For the time being, observe how all other dimensional constraints are derived from the hole diameter. Next, I define a valid set of values for the hole diameter. I do this by specifying the valid values in a table that is called the family table. I add this dimension to the family table by creating a family table column and linking it to the dimension. I now add some rows and define the valid values. Let's test this again. Notice how the name of the dimensional constraint appears in the size selection dialog box. This is one reason why we must name the constraints meaningfully. Moving on, I define an insertion point for the spacer, and then I constrain it so it won't move when I resize the part. I must also ensure that these center lines get created on the correct layer. So, I move them to the layer assigned to center lines. Next, we will constrain the center line in such a way that the overshoot is controlled automatically by the drafting standard. First, I create a user parameter that is named overshoot. The name is crucial as the system takes control of this parameter and assigns values to it every time I insert the spacer in a drawing. Next, I constrain the center line using this parameter. To constrain it, I add some construction geometry. I switch to the construction geometry layer and add a circle. I constrain it so that it will stay concentric to this hole. After that, I fix the ends of the center line to the construction circle. Now I add a dimensional constraint to fix the diameter of the construction circle to the hole diameter plus the overshoot. I save and test the spacer. If you notice, the construction circle is not visible when I insert the spacer. Now let's add another view to this part. Again, we start with the drawing and add the view geometry to the content library. When I save it as a view of the same part I created earlier. Now I add the geometrical constraints and the dimensional constraints. Notice once again how I use the name hole diameter for this dimensional constraint. By choosing this name, I tie the dimensional constraint to the hole diameter family table column. Next, I change the layer of these lines so that they indicate hidden edges. I do the same for the center line. Finally, I add bill of materials information to this part. I start by adding a column for the material, and I link it to the Material 1 component property. Since all spacers are manufactured in mild steel, I will set it as global so that it has the same value across all rows. I add a column called Name and link it to the Description 1 component property. In the bill of materials, the name of the part is derived from the standard and description component properties. I finally select this checkbox to ensure that the size selection dialog box will not prompt me for the value of this column when I insert the spacer in the drawing. I specify a value for each row. I save and I am done. There are many other things you can do, such as making a dimensional constraint draggable and set up hatches and arrays that adjust according to the size of the part. Look at the samples we provided and also look up help for more information.